Hello, this is Group 25. In this presentation, we will be discussing Credit 4 from Energy and Atmosphere, Demand Response. This credit applies up to 2 points for project under new construction, core and shell, schools, retail, data centers, warehouses and distribution centers, hospitality, and healthcare categories. A project will earn 1 credit if no demand response program is available and 2 points if an existing demand response program is available. By definition, demand response refers to a change in electricity use by demand-side resources from their normal consumption patterns. This change is in response to changes in the price of electricity or to incentive payments designed to induce lower electricity use at times of high wholesale market prices or when system reliability is jeopardized. Therefore, a demand response event refers to the time when utility providers call for program participants to change their electricity use pattern. In addition, here are several terms that will better help you understand this section. Load shedding is an intentional action by a utility provider to reduce the load on the system, which is usually conducted during emergency periods, such as capacity shortages, system instability, or voltage control. Peak demand is the maximum electricity load at a specific point in time or over a period of time. Lastly, permanent peak load shifting refers to the transfer of energy consumption to off-peak hours, when demand for power is lower and energy is therefore less expensive. The intent of this credit is to reduce the environmental and economic harms associated with fossil fuel energy by increasing self-supply of renewable energy. There are several reasons behind the intent. Electricity in urban area grid must respond quickly to keep the system operating in balance, reliably and at reasonable cost. Yet, renewable energy produced on-site protects projects from energy price volatility and reliance on the grid while reducing wasted energy loss in transmission. Ultimately, renewable energy production contributes to reducing a country's demand for imported energy. There are 2 cases for the requirement of this credit. One refers to the case where the project has an existing demand response program available, eligible for 2 credits, and case 2 for projects without an existing DR program available, eligible for 1 credit.
For case 1, the project team must design a system with the capability for real-time, fully automated demand response based on external initiation by a demand response program provider. However, a semi-automated demand response may be utilized in practice. The project team must also enroll in a minimum 1-year demand response participation amount contractual commitment with a qualified demand response program provider with the intention of multi-year renewal for at least 10% of the estimated peak electricity demand. The peak demand is determined under EA prerequisite minimum energy performance. In addition, the project team must develop a comprehensive plan for meeting the contractual commitment during a demand response event. Furthermore, the project team must include the demand response processes in the scope of work for the commissioning authority, including participation in at least 1 full test of the demand response plan. For case 2, the project team must provide infrastructure to take advantage of future demand response programs or dynamic real-time pricing programs. The project team must also install interval recording meters with communications and ability for the building automation system to accept an external price or control signal. In addition, the project team must develop a comprehensive plan for shedding at least 10% of building estimated peak electricity demand. Furthermore, the project team must include the demand response processes in the scope of work for the commissioning authority, including participation in at least 1 full test of the demand response plan. Lastly, the project team must contact local utility representatives to discuss participation in future demand response programs.
There are 6 separate steps for applying the appropriate project for this credit. The credit workflow should begin with deciding which case to apply the project to. Design the system for peak demand reduction and guarantee demand response availability in the commissioning part of the project. The first step is to determine the applicable case. If a current demand response program is available, select an appropriate program and enroll in a contract of at least 1 year. Also, the project's participation into a demand response program requires an agreement with the DR provider to provide curtailment of building energy demand. If no demand response program is available, the project team needs to design a system to accommodate future DR programs and contact the local utility service provider to express interest in participating in a DR program in the future. The second step is to design a system to accept external signals. The project team is required to incorporate the capability for a demand response program into the design process, as indicated in the credit requirement by the utility provider if applicable. In addition, systems must be capable of acting on an external signal, but their actual operation could either be fully or semi-automated. The third step is to determine peak demand reduction requirement. To establish the peak demand estimate, projects that use modeling to achieve EA prerequisite minimum energy performance should take the estimated peak from the model. On the other hand, projects that followed a prescriptive path may use base peak load calculations to estimate overall building peak demand, or other methods or calculations based on information available. The minimum peak demand reduction required is equal to 10% of the peak demand as shown in equation 1.
Step 4 is to develop strategies for peak demand reduction. Project teams may reduce peak demand by modifying consumption from various end-use systems such as HVAC and lighting. One strategy to reduce demand is to make global temperature adjustments to increase cooling set points or decrease heating set points for an entire facility for a given period. Facilities managers may find that some occupants prefer the temperatures under demand response events, indicating the possibility of making permanent changes to the set points. Another strategy to reduce demand is turning off decorative features like fountains and video displays, which reduces energy consumption without affecting worker productivity. A strategy for hospitality and healthcare facilities to reduce demand is to reschedule housekeeping activities such as dishwashing and laundry. Step 5 is to prepare a plan for peak demand reduction. The training plan and objectives for those employees directly responsible for executing the demand response action plan should address individual assignments, event signals, communication protocols, recovery, reporting, and clear status. The demand response operations team members, which may include the demand response coordinator, facilities manager, and demand response action plan manager, must agree with the content of the plan, since they will be implementing it. Projects must develop a comprehensive action plan to address roles, responsibilities, and expectations for a demand response event. The plan should address the potential for demand response participation, such as curtailment of peak demand and the elected demand response value, or schedule values, in kilowatts to be registered with the demand response provider. The plan should also address an event notification process for demand response events, such as a phone call, an alarm with countdown clock, or a signal to a BAS console, depending on the degree of program automation. The plan should also address detailed procedures and responses to execute the program measures consistent with the demand response contract. The plan should also address a contract and the registered demand response participation amount, including the notification method, specific actions, order of execution, load monitoring process, and post-event recovery process. The plan should also address an energy management team responsible for coordinating with the program provider, the facilities department, and internal risk management, including event notification and response, revenue settlements, contract administration, assessments, action fulfillment, employee awareness training, readiness drills, and energy management reporting. Lastly, the plan should address a description of end-use systems that will be affected, such as HVAC or lighting, on a standalone or integrated basis during participation in demand response events. Step 6 is to include demand response in commissioning. The project team must coordinate with the CXA to include a review of the demand response plan in the commissioning of the building system test procedures to verify the ability to handle an externally initiated demand response event. The CX plan must include at least one performance test of the full demand response plan to verify that all equipment responds as planned and that all responsible parties understand their roles. The required documentation for Case 1 includes proof of enrollment in a demand response program, evidence of ability to shed 10% of peak demand, confirmation that system is capable of receiving and acting on external signal, action plan for meeting reduction requirement during event, and inclusion of demand response in CXA systems testing plan. Case 2 requires all the mentioned documentation except for proof of enrollment in a demand response program.